All right, so this is Stephen Chin for another night hacking interview. We're going to be chatting here during the break at JFocus and discussing Java 8 and Lambdas. And my guest here is Venkat Subramanian. And you need no introduction. You just recently wrote a book on Java 8 Lambdas, which is in beta right now. And you're also a very prolific speaker throughout the world.
Well, thank you.
So you've been doing a whole lot of work with Lambdas, but one thing which I think I get a lot of questions about is why do we need Lambdas? Isn't it just gonna make things harder and more difficult for folks to understand? What's the benefit?
I think that's if you really look at languages out there today, ignoring Java for a second, there's no mainstream language today that doesn't have Lambda expressions. I mean, for crying out loud, even C++ has Lambda expressions.
I was going to give you like the original C, C minus.
Well, okay.
I take your point.
The mainstream languages.
I take your point.
C++ is really, I consider them to be a combination of C and C++. And in a way, the biggest change in Java is going to be in the minds of the programmers. This is very high time. But to answer the question, what's the real benefit? And the real benefit is that Lambda expressions do correctly a lot of things we have been struggling to do. We all know this very well. Mutability is evil. When you look at mutability, we have done mutability in Java for a long time. So mutability is something we're used to. Sharing is not a bad thing. Remember what mom told us, right? Sharing is good. But shared mutability is pure evil.
Yes.
And the minute we bring shared mutability, all kinds of things happen. And even when we deal with mutability, as smart as we are as human beings, we are not good at juggling things. So when we change the state, we easily introduce bugs in code. So the functional style of programming, the functional paradigm, really is assignmentless programming. And
Okay. So your argument is about kind of style and correctness of programming and how you write. I've heard other people expound that it's all about performance.
Well,
being able to take advantage of multi-core systems. So which do you think is the real, what should Java developers care about?
Make it work, make it better. If my code is broken, how does it matter it's fastly broken? Right? So my first argument is, let's get the code correct.
Yeah.
In a way, when the code becomes less error prone, easier to express, easier to write, that code is easy to make concurrent. That code is easy to improve performance. A badly written code with bugs is not easy to maintain. So I would say I'm not ignoring performance. You cannot have a good solution to these problems without performance. But that's not where I want to start, that's where I want to end. So when I can have a cleaner code that's easier to express, easier to maintain, I can get to a better quality code. And as a result, I can improve performance.
So we've been chatting for a while, and you're claiming that it's easier to write correct code with Java 8.
Yeah.
Can you show me an example of this?
I'm going to start with extremely trivial, something very trivial. When you look at a piece of code, you want to understand what that code is doing very quickly. And the word I want to start out with, if we can start with this word here, I want to start with the word ceremony. Nobody likes ceremony. Ceremony is what you have to do before you get to really do what you really want to do. And we can see this in kids. Kids don't like ceremony, right? They want to have fun.
No.
Well, programmers are the same way. We want to get directly to what we want to do. So let's take something extremely trivial. Let's say for a minute I have a thread and I have to, let's say thread class. And sure, in 2014, nobody would create a thread class like this. We'll use executor services. But ignore that for a minute. Let's keep it extremely simple. Now I want to start a thread. So what would I do? I would say thread.start. And then I'm going to launch a thread. I would say thread.join, in this case, to ask the thread to finish up. And I'm going to simply say over here, let's say in main. And when I'm done with it, I'll just simply say done. So I want to try this out. But of course, I got to give the code for what I want to do in this other thread. Well, let's deal with one ceremony real quick here. We got to deal with exceptions. And I'm just going to throw that in there because I don't care about that exception. Well, what about this though? We're going to say new runnable, and then within this runnable, I'm going to say public void run, and within this run method, I'm going to say in another thread like that. So if I try to run this code and see what it produces, we can see that it says in main, that other code was run in another thread, and then we can see the done happening. But if you look at this code, what I really wanted was this one line of code, which I wanted to send off and run in another thread. But in order to do that, I had to write this part, and I had to write that part.
That's some nice ceremony.
That's a ceremony, right? And in a sense, the more complex code becomes, the more fluffy and ceremonious it becomes. When you have a lot of ceremony around you, and you get a spark of idea and say, hey, cool, why don't we try this? And then you say, oh, no, you know what? In order to try that brilliant idea, I got to write all that stupid code. And if you would note, if people won't take any offense, what we are using here is called anonymous inner classes. I want to call anonymous inner classes as missed opportunity. Because in Java 1.1, we had this opportunity to introduce Lambda expressions instead of using anonymous inner classes. We have an opportunity to fix that missed opportunity. So what we can do here is, notice the highlighted part. What are we really saying here? We're saying, I want to send to another thread a function. I don't want this function to take any parameters. So the essence starts right over here. Everything before that is a ceremony. You and I don't care about the word run. We care about what parameter are we sending. So I'm going to strip out everything before that ceremony. Then I'm going to come back here and say, when that parameter is received, I want to do this operation, and I'm going to remove everything to the right of that ceremony. So we took Java code and we made it lighter than we had before. And the code still works. So my question is, why are we adding fluff when a simpler code actually can work? So in a sense, rather than using an anonymous inner class, we're using an anonymous function.
Yeah.
This function has no name, we don't care. We can let Java infer the return type. We brought it to the essence. We said, here is the parameter that I'm sending to this function, in this case, none. And here is the body of the code I want to execute. So most of us would argue functions have four things, right? We got a name, we got a parameter list, we got a return type, and the body. Well, name is not important. The body is the most important. We have that highlighted. The parameter list is to the left of the arrow. And of course, the return type is inferred. So we got down to the absolute essence.
So, all right, so you got to the bare essence. Now, something I think a lot of folks struggle with when they first try Lambdas.
Yeah.
And you can help me out with this. You're going to teach me this. So you went from an anonymous inner class to a Lambda, and the program behaved the same, but a Lambda is not the same as an anonymous inner class. So what are the differences? Like, what do I have to watch out for when I start converting my code to Lambdas?
That's actually a really good question. If you look at this code for just a second, and if you were to tell yourselves, let's kind of get rid of some of these guys just to understand this part better. If you look at this part, a minute ago we had a runnable. And right off the bat, we converted a runnable into an instance of a runnable into a Lambda expression. So at initial sight, we may feel like, oh, this is just a syntactical sugar. We replaced a Lambda expression where an anonymous inner class was expected. But that observation is a bit naive. Brian Getz talks about this as, let's go home for the dinner solution, where they could have done something like this, and that would have landed them in a lot of trouble. And the reason is this. So if you go back to runnable for a second, and if you had written, for example, the run method as we did, let's ignore the implementation for a minute, and now there's a problem inherently in this code. So to understand this, let me get back here to my directory here to see what we have on our hand. So let's take a look at what we created when we compiled this code. So if I go back and this code doesn't produce any output, but let's take a look at the what we have here on our hand. If you look at the classes directory, you will notice that, ignore all the other things I have in this example, I got sample, but notice sample $1.
Yes.
Well, if I'm going to use anonymous inner classes, I might have replaced this code very easily with something along the lines of this little code with just a little implementation of the Lambda, which means I would be prompted to use a lot of Lambda expressions. And if those were really replaced by just the anonymous inner classes in my code, so every Lambda expression I use would turn out to be something like this. Well, if I try this, to go through and try to do it this way, well, actually, let's go ahead and remove these thread for a second, pardon me here. So if I were to go through and implement it this way, let's just go ahead and say I want to copy this over. Well, the code basically compiles, but we got a bigger problem on our hand. If you look under the hood now, we got several anonymous inner classes. That would explode.
That's quite a lot of static footprint you're adding to your...
Well, not only is it a static footprint, now you're overheating the virtual machine because it's got to start loading up all of these.
Yep.
And that's going to be impact on performance as well, not to mention other problems. However, the beauty is this. If I go back to this code for a second and replace this with Lambda expressions, and let's just say here, just an empty string for a purpose. So if I were to use many of these now, so notice, even though we were able to replace the Lambda expressions where anonymous inner class was used a minute ago, now if I go back and look at it, there is quietness. All those inner classes we had went away. So what's really happening? Well, in order to understand what's really happening, let's go back here for a second and look at Java P and with the -C option, which is an alias on my machine. And let's look at the sample class. Well, what ends up happening here is when we are making the call to that function, it results into an invoke dynamic. So in a sense, a feature that was introduced, as I like to say, as an act of kindness for dynamically typed languages, ended up being the fundamental feature for supporting Lambda expressions. That was like an aha moment for me.
So I think you might be misinterpreting the order of events there.
Okay, tell me.
So you're assuming invoke dynamic came along to help other people, and then they're like, oh, this would be useful for lambdas. I would assert it might have happened the other way.
Well, that's probably a debate to be had with the people.
We should get Mark to answer that question.
Yes, I would love to hear that, absolutely. But beauty is this, right? Because Java 7 had Lambda expressions, invoke dynamic, way before. So we should maybe call him and ask him. And to me, that was the aha moment, is that a feature at the bytecode level becomes so vital to implement this feature. So what's really happening here? What's happening here is the JIT compiler can say, I can rewire this call directly to the method I'm implementing rather than going through the overhead of creating an anonymous inner class and routing the call to that instance. And so it's a lot more than syntax sugar, even at the bytecode level, and definitely also at our programming level as well, from the API point of view.
No, it makes a huge difference. And I've decompiled JVM languages on Java 6 and previous, and if you look at the amount of classes which get generated as a result of lambdas and other abstractions they provide, you will be surprised at how bloated some of your bytecode gets.
Yep, very true.
Okay, so that's one difference between the lambdaized version and the original. Is there anything else which is?
Well, so here I mentioned in the beginning that the biggest change in Java 8 is in the minds of the programmers.
Yes.
So we have to rewire ourselves. If you really think about it, there's not a whole lot of syntax to learn. I think we could learn the syntax within about an hour to 2 hours. But to use those syntax to rewire our mind to benefit from this is where the real benefit is. Mm-hmm. For example, a common operation is to read certain content from a directory. Let's say I want to process the members of the current directory. how would I go about using those information? So for example, let's take the current directory itself. So I'm going to say over here, let's say java.io.star. And over here, I'm going to go ahead and say, bring the current directory. So we'll say over here, current dir and equals new file. And let's mention the current directory itself. And I want to loop through and find all the files in the current directory. So we could say file, we could say children equals. And in this case, let's say current directory dot list files. Well, once I get the list of files, I could use the traditional for loop to iterate over each and every element in this collection. So I could say file, we could say, for example, child, which comes from children, and then we could maybe just output maybe a child dot, let's say, let's just output the file object itself. Let's keep simple, keep it simple.
This code is looking like something very familiar, like I might have written 1,000 or
a million times. Nothing to be proud about, but we've done it so many times. But here's one of the key differences. When you look at a for loop gives you, there are so many levels of details hidden in this. If you look at a for loop gives you exactly what you ask for. Loop through sequentially. In fact, if you notice this, there is one huge fundamental difference. We all want to claim that Java is OO, right? But if you look at this code, the word is uh-oh, right? Because if you look at the for loop, this is not polymorphic at all. It says, I am going to do what I do on the collection you give me. Well, in a good object-oriented language, we would use polymorphism. And what's the benefit of polymorphism? Well, polymorphism says, go ahead and call the method, focus on what you want to do, relieve yourselves of the details of how you will do it. This code says, this is exactly how I'm going to loop. So as a result, this doesn't give the flexibilities of concurrency and performance we talked about earlier. Well, let's see how we're going to do this a little differently. So rather than going through this, we could try a very small difference. We could say, for example, children, so we could say stream of, let's say children. So I'm getting a stream. Stream in Java 8 is a very fancy iterator. So we got a stream object. So of course for this, I'm going to include over here util.stream. And now that I have a stream on my hand, I'm going to say dot for each. And I'm going to use the lambdas that we talked about. So file, and I'm going to simply output the file that we have on our hand. So in this case, we took the traditional for loop and reverted to something very simple, which is simply a for each statement to do that. Now, it looks like a very small change, but the benefit is phenomenal. I'll tell you how it's phenomenal. To understand this, let's say, for a minute we have a static method called process file, where this takes a file as a parameter, just for illustration purpose. And then within this, let me just print the file. So same change as we did before. So right here, rather than calling this system.out, I'm going to simply forward this back to process file and send the file over. So if I had written this as a regular for loop, it would have done the same thing as well. However, the beauty of this is, if this code were to take a little bit of time, let's say, so try, and then let's say thread.sleep, let's say this is going to take a second to run, and just over here, and now if I run this code, you can see it is taking a while to respond, because it's taking the time to run through all of these. You can see the beach ball spinning.
No, I mean, a lot of cases when you're doing stuff with file systems or networks or things, there's delays and...
Absolutely.
Yeah.
So, but you come along and say, wouldn't it be so easy to make this concurrent?
Oh, yeah, I remember there was this fork join. You create this complicated interclass thing. And
fork join is awesome for what it does. But for us to use it, I call it the tax on programmers, right? It is something you have to take the burden to write the code. And when you're done, your nice little for loop is no longer a nice little for loop. It's
Yeah.
turned into a monster in front of you. Well, how about this? We could just say parallel, if I know how to spell parallel, dot for each, and now we are asking it to run this as a parallel collection rather than as a sequential collection. So, in other words, go back to the code we had a second ago. We had this a second ago, and this was taking the beach ball and the spinning. And all I'm saying here is, now that we realize we can do this quicker in a multi-core processor, rather than spinning through the beach ball, why don't we simply ask him to do parallel? So parallel on this, and then we can fire it up, and you
Yeah.
can see that the result is going to show up right away.
No, that's a huge difference.
Huge
and
difference.
Not a big difference in the amount of code you had to write to do it.
So
So as a programmer, you'd probably be more likely to use fork join, having a convenient mechanism for applying it with lambdas.
Right, and the point I really like about this, you're absolutely right, and the point I like about this is, they didn't make concurrency implicit. They made it explicit. I called it the master switch. So you had to flip the switch, so you
Yeah.
as a programmer is still in control. But once you flip the switch, you didn't have to struggle to modify the code structure.
So I don't know. I think that you said that we wanted to get down to kind of the simplest and the most elegant way of writing it, but that lambda still seems like a little bit superfluous.
Okay, so,
You have a file, and then you're passing it to a method, and then you're passing the file as the parameter.
well, if you are into patterns, I have a name for this pattern.
Yeah,
Notice how we receive the file, and we pass the file here.
yeah.
My favorite name for this pattern is called the office space pattern.
Office space.
Yes. Remember an office space movie? Tom, what do you do here? I take the requirements from the business people and I give it to the programmers. So that's what this is doing. So we can quickly say here, sample process file and replace that with a method reference.
Oh.
And that can remove further ceremony in cases as simple as using the office space pattern.
I like the pattern. Yeah, no, I'm happy now. Yeah, I guess the JDK team did okay.
Oh, they did wonderful, in my opinion.
Yeah,
I'm all praises for them.
Good enough. Yeah, no, that's very elegant now.
And what excites me about this is the ability to express our ideas. To me, programming is these transitions of aha ideas to seeing them implemented. And removing ceremony from the code is the way that can get us there. Well, Java will still have a certain amount of ceremony, no doubt about it, right? Because that's the baggage we have to carry with us. But for the new features, we got a lot less ceremony than we used to. And I think that's a very welcome sign. And this is something that the Java programmers out there don't have to say, well, we can't do it. If they're willing and interested in improving their skills, they can reach out and write really good quality code.
Okay, so here's a different line of questioning. And so in this example, you're showing us an existing JDK API, which they've applied lambdas to make simpler, right? But how do you see other third-party or open source or other projects applying lambdas to make their own APIs simpler?
I think there's going to be an explosion of feature set that uses Lambda expressions moving forward. And in two main areas. The first is, let's take existing methods and APIs right now, whatever people already have out there. So if somebody has a method, let's say, for example, I've got a method, we'll call it foo for a minute, and my method foo is accepting some receiver, whatever that receiver is going to be. Mm-hmm. And all I'm going to do within this is say receiver dot, let's say, call. That's all I'm doing. Now, what in the world is this receiver? We could say, for example, interface receiver, and the receiver has a method, let's say, called call, and of course, that's an interface. So if I want to call that method that I have right here, the foo method, so I'm going to call foo. Imagine this is an existing library that was published, let's say, in Java 1.5.
Yeah.
I've been around
Yeah.
for several years. Well, I can today come and call this method. I could have said new receiver here, and I would have said void, and I would have said call, and then I would have said something like, called here. Well, I can right off the bat take that very code and I can replace it with just a Lambda expression without any change whatsoever to that library.
Wait. But that class library existed before lambdas were part of the language.
That's correct. But when you recompile your code right here, the Java compiler says, oh, you have a single abstract method interface. And wherever you have a single abstract method interface, those are called functional interfaces in Java. And normally in Java 8, you would say functional interface, but this is optional. And they very tactfully made it optional because they want to take existing interfaces that are single abstract method interfaces.
So your point is that a lot of third-party libraries you can already use lambdas with.
Absolutely, right off the bat.
Yep.
But the next level of improvement is going to be where the third-party libraries say, rather than returning a collection back to you, why don't I instead receive a function from you and apply the function on the collection I have? So in other words, we have been exchanging objects back and forth. Now we begin to think, maybe we shouldn't exchange objects. Instead, we should exchange functions.
Yeah.
So libraries will mature to receive functions rather than objects, and that gives us lazy evaluation capabilities.
Okay, so let's say I have an existing API, and I want to add some new methods to my interface, which now accept functions.
Yep.
But I can't do that.
Well, you already can, because we just did. For example, right off the bat, foo was receiving a function, and if you notice, we passed a function right there.
Okay. So that works. But if I want to add a new function,
absolutely, you would have to either define your own interface,
yeah,
or you say, why do I care about a new interface? And Java itself provides some really useful interfaces. One of them is called consumer, where a consumer simply swallows everything you give it. So if I'm designing an API, a library, which is supposed to give you control to do some stuff, but I don't expect anything back from you, then I will design my method to receive a consumer as a parameter. On the other hand, if you're going to give me a logic, a lazy evaluation of whether I should do some work or avoid that work, then I'm going to send you a predicate. I'm sorry, you're going to send me a predicate. So I'm going to expect a predicate back from you. But on the other hand, if I want to apply a strategy pattern where I have some work cut out for me, but in the middle I want to yield control to you and say, hey, could you do this part and give me back a result? Then I'm going to give you a function where the function would take in some argument, do some work, a unit of work, and give back a result that I can continue processing.
So they've already laid the groundwork for some common patterns for functional interfaces.
So one of the things I realized was the design patterns we are used to programming in Java just became lightweight.
Yeah.
Strategy becomes a couple of lines of code. Decorator pattern can be implemented without writing a single additional class, but using Lambda expressions. So it gives a new birth to these patterns in terms of lightweight implementation. And that is exciting to look at the code evolve right in front of us. And that is pretty encouraging in my opinion.
Okay, so getting back to my question about libraries, you probably see them evolving to take advantage
absolutely
of lambdas.
So evolving in two ways. One, we will evolve to use them in a much more lighter way already without them doing any work. And the libraries will evolve to start receiving functions rather than objects. And then that will give lazy evaluation and other benefits as well.
Cool.
Exciting times for sure.
Yeah, no, definitely. So what's the response been like about, you've been speaking and talking about lambdas. Do you think the Java development community is ready for this?
I think that it's like wildfire. I saw in Java 1 last year, there were, if my count is right, 6 to 8 talks on Lambda expressions. Every single one of them was packed. People in long lines, they couldn't get in. And so Java 8 was a huge appeal in the conference.
Yeah.
I've been speaking in other conferences since then, Yesterday I had a workshop, and the room was packed with close to 300 people in there. So
and
absolutely.
we were actually competing against you with a lab, and our lab was packed while your workshop was packed.
That shows the excitement people are having about this. Of course, there are a large number of people who are also waiting for Java 8 to actually ship. But
Yeah.
with that being so near, I think it's definitely going to be a big win. I have no doubt about it. And also, in all the books I've sold, I'm seeing a huge interest for the beta of my book as well. Relatively speaking, more books being sold in the beta than I've ever seen before.
So a lot of interest in folks reading about and learning Lambdas
Absolutely.
and starting to apply it even before the release is out.
Absolutely. Yeah.
Okay, so I was going to diverge topics slightly from Lambdas. Anything else you want to cover on Lambdas?
Well, my suggestion is it's a better way of programming. So here's one thing I want to mention before we leave this topic. This is not a newfangled idea. This has been around for a good 40, 50, 60 years. It is new to Java, not new to programming. And so the risks are extremely minimal. It's a tried out method. It's a step in the right direction. And it's high time that programmers actually make use of it. And I'm excited that they have the opportunity to do that in Java today.
Yeah, no, it's a good point. So what I wanted to ask you a bit about is Java 8 is Lambdas plus a whole bunch of other things. What else are you personally excited about in the Java 8 release?
To me, more than Lambdas, there are two other things that are pretty interesting in Java 8. I'm more interested in the language features. That's what I focus on, not including other things. One is streams. Now, when I started digging into Java, I would say Lambdas are the gateway drug. Streams are the real addiction. Because once you taste the stream, you are going to be in it for a long haul. Because the power of streams is simply amazing. The way they provide function composition, the way they provide lazy evaluation, the way they provide parallelism, it is amazingly cool. So to me, more than Lambda expression is just what draws you in. Stream is the one that's going to keep you in.
Yeah, even though the Stream API is simply an API built using Lambdas as a feature, my guess is for a lot of people, those will be inseparable in terms of how they think about it.
Absolutely, I totally agree. And the other one I think is fairly interesting, though we still have to figure out whether it's going to become a pattern or an anti-pattern, is the default methods.
Oh, you mean multiple inheritance?
Well, yes. At least it doesn't give you the problem of multiple inheritance, but it's something that I think is easy to abuse. And I think there is a borderline use case where it can be useful.
Yeah.
And then that tipping point is really quick, and then we can get into a huge abuse of the feature. So I think for what it's worth, it's useful, but we have to be very careful using it as well, I think. But those are the two things that excite me.
It solves a real problem for API designers.
Absolutely.
It lets you do migration rather than rewriting APIs, because now you can add methods to interfaces, but you think some people are going to cleverly abuse it.
Oh, of course. We are good at it as programmers. I would do that.
Are you going to do a session on that?
Maybe next year.
Method references at their worst?
Maybe next year, absolutely. I'm sure there'll be opportunities for anti-patterns and talk about the experience we learned from it.
Yeah. Like that's how people learn. You have to show them what not to do.
Well, sure. But we learn by doing what not to do as well.
Exactly.
And then we say, oh, that was not a good idea. Let's not do it. Absolutely.
Cool.
Yeah.
So I want to thank you very much for the short interview on the JFocus stage here. It's always a pleasure.
Thank you. Thanks for the opportunity. Thrilled to always talk to you. And thanks for having me.
And I believe, do you have any more sessions upcoming?
I do. I have one on Java 8 today and multiple languages on the JVM tomorrow.
Yeah.
And then I'm doing a week-long, 2 days Java 8 deep dive training on Thursday and Friday as well.
Cool. Very good. Thanks very much.
Pleasure. Thank you.